Yeah, I'm not sharing it. Should be coming up now.
How you do?
So while Jim gets set up, I'm Kumar. I manage the WAS, AppNav, which we're going to present today. The visibility control features for the ISR. So Jim, he's one of our rockstar KMEs. He's going to present it. I'll chime in case you guys have any questions on WAS or anything else. Feel free to ask, and I'll chime in. And I will say this while he gets set up. So I was getting ready this morning. I have a daughter who goes to 2nd grade. And I'm just chatting with her. I'm wearing my regular slacks, my own shirt, and I tell her, some of the conversation goes. I tell her I'm meeting a bunch of bloggers. We're upstairs. She screams, "Mommy, Daddy's gonna meet bloggers!" Damn, I don't get this reaction for my job. Turns out she's been visiting this Justin Bieber blog. So I did dress down. So at this point, you guys are wearing shirts and sorry, man. I didn't ruffle that time.
We don't have the Elmo hoodie going.
I know we don't know Justin Bieber.
Yeah, sorry.
You got Bieber?
I can't believe free backstage passes.
That is on call.
She could come along to a packet pushers recording. It's really not that fun.
That's funny.
You guys see what's being shared now?
Yeah. WAS with AppNav. Our name.
Stick this in your pocket. Your cell phone not in there?
Perfect, that's okay. I'll take it out.
Yeah, just put your cell phone in.
Are you getting my video feed?
Yes.
Yes. It's all good here. By the way, guys, I'm Hugh Vliegen.
I'm Director Technical Marketing for the Service Routing Group. So a lot of the teammates here are doing demos, they're reporting to me, and I'm working a lot with Kumar over there on WAS and ABC. So
that's right. Usually Hugo's a cooler one. Today I beat him because I got the hoodie.
Sorry,
Just
I have to look like a teammate.
Just today. Jim, it's all you, man. Go for it.
Fantastic. Well, good morning, everybody. My name is Jim Sangeeth, and I'm an engineer in the Technical Marketing Group. I bid you all greetings this morning from Chicago, home for what will be the future 2012 Super Bowl champion Chicago Bears.
I don't think so, pal.
Good luck.
Oh, God.
All right, so what we're here to do today, we're going to go over the component for what we just introduced, which is called AppNav. So AppNav, which is short for Application Navigator. So what I'm going to do is I'm going to go over real quickly what has been the sort of the challenge, right, in the data center. In other words, why do we create AppNav, right? The primary problems around scaling, operational complexity, and then some of the issues that seem to plague the market around WAN optimization, mainly things like asymmetric routing. AppNav solution specifically and how it addresses those previous points. Talk through then a step-by-step flow for how our stateful knowledge of very detailed flow knowledge to address these problems. Well, a step-by-step detailed example for how we deal with asymmetric routing. What I'm sure you'll see is that it's turned into a very, very trivial matter. What I'm going to do is I'm going to turn and do a live demonstration. What I'm going to do is I'm going to have you connect. We'll connect to we'll actually walk through the AppNav system where we'll now sort of apply what are some of those principles talked about in the earlier steps. Sort of how far we've taken this platform now. Okay. So first, when we look at sort of the data center problem, so traditionally as in WAN optimization would get deployed, one of the approaches we've done is that you would put the WAN optimization resources in line, right? Basically putting them in path, and the reasons for doing this is that it was simplicity. Code changes in network configuration will need to be required. Run the devices in and off you went. What you run into is that you run into a scaling problem very quickly because you can only daisy chain so many of these things together. At the same time, there is no way in the traditional way by which you could then decouple what was the interception from distribution and WAN optimization process. That everything had to be born on the same CPU. WCCP was nice in the fact that it broke the mold of inline and that you can now create and have more servers to scale horizontally. The only thing with WCCP is that it was undeterministic in terms of where the content was coming from outside of the source IP addresses, and then you start running into a problem that it really isn't flow or application aware. Right? So now you start here in the existing way by which hashing was done, is you wind up very easily misskewing the load, and you start to overload individual resources that the BCP is distributing to. Along came the next step, was say, let's apply some more intelligence into the BCP. So along came was the idea of doing mass-based flow distribution. Source IP address and some port data. Now they can leverage ACL redirect lists now distribute things, and it achieves it and allows us being able to load a little bit more evenly among the cluster. The next problem you run into, though, is that in order to do this in most any type of reasonable size deployment, is the number of redirect ACLs becomes several hundred lines long, and I've seen 600, 700. So the problem now you also get is that routers tend to now run these, execute these ACL functions using TCAM memory, so that the ACL can be executed in optimal speed. So now the utilizing this large amount of redirect ACL is the router's TCAM space gets consumed very quickly, and when you start to run into larger mass bits in order to accommodate this granularity, how you wind up doing even more CPU utilization. Right? So now you're really just sucking the resource out of the core platform pretty badly. So what AppNav does is if you look at what we sort of just want on those points, is that there's basically, you can group it into saying is that it deals with having to address interception, redirection, load distribution, managing the optimization of resources, as well as dealing with matters such as high availability and the asymmetric routing. So what we do to solve the problem is we basically take nearly all that capability and we run it natively within AppNav. And so basically what AppNav is, when you look at it sort of by definition, is we leverage the concept of virtualization. And so AppNav virtualizes WAN optimization resources and builds those into what we call elastic pools of resources. Resources that now can be brought to bear with a very granular level knowledge of the system data and flow information. What it does, it actually runs on an IOM module that just slides right into the inline on our chassis. So there's no additional chassis sort of required to make the system work. It actually doesn't take anything away from the host chassis as well, so it doesn't compromise the performance of it. By doing it, it runs its own CPU, its own memory, its own network interface resource. It also doesn't then deprive the host appliance from becoming an AppNav, a resource for AppNav to use. So that host chassis that's running it can also be part of that elastic pool. When we built it out as well by design, we came out here with the AppNav cluster. Now basically, in our first release, going up to supporting 8 controllers within a cluster, and up to 32 individual WAS accelerators within that. Those clusters then can also support up to 1 million concurrent TCP connections, while at the same time also being able to go up to about 1 million connections up in pass-through. Run AppNav in both what's called off-path, or in-path or off-path or out-of-path mode, meaning that now in a similar fashion where you saw it being in-path or within line. But the difference now is where AppNav is in line is it now just takes that inline and performs, distributes that out to the WAS accelerator. Now the WAS. Yes.
Can you re-say whatever your last sentence was, because you cut out? And keep
Oh,
your
I'm sorry.
mouth near the speaker, please, if you can.
Not sure yet. I have a headset on. Let me know if it happens again. I don't know, maybe the battery's going.
Okay.
So the AppNav controller can be deployed in-path or out-of-path. The difference for how when AppNav runs in-path is, as opposed to when you're running just normal accelerators in-path, is AppNav just then takes the interception function and then using its own policies does the distribution to the WAS accelerator. So the one device no longer has to bear all of that overhead of CPU of doing the optimization, compression, and functions. So now it allows a much broader amount of scalability, which is why the cluster can now run to such a high number of concurrent connections. Now, what does this mean if you actually look at it practically? So when you look at an application flow distribution example, so now we're used to deploy resources, and pretty much any type of server-based resource, you pretty much scale it based on this sort of broad assumption of averages and saying, well, I'm going to put this big old box in here because I need to be able to support some number of capacity, right? The bandwidth connections or such. Well, now with AppNav is because we have that granular flow control, is now you can deploy the WAN optimization resource that actually is best matched to the specific application that it's using. So, for example, let's say you have applications that are very CPU intensive. So things like encrypted traffic, like SSL or eMAPI that's used from between an Outlook and Exchange. Well, now what we can do is we can tune and run, and AppNav can direct that traffic flows to specific accelerators, hardware accelerators, that are now performance tuned for encrypted traffic. Other types of flows like virtual desktoping that are CPU and yet throughput sensitive in nature, now what we can do is we can direct those traffics specifically through virtualized instances, where now those instances can be spun up in more demand as more types of virtual desktop usage takes place. For those types of applications that are then storage intensive, things like CIFS or file shares or HTTP traffic, now can also go to different types of virtualized environments that now are directly connected to where the corporate data is stored, mainly usually in large SAN repositories. The nice bit of odds we came in as well is that we took this in, and when we came out the door, we didn't sort of say, okay, now you're going to come into this in our new release, and by the way, everything that you've got and brought up to this point in time is now all dead and buried. Any of the previous generation hardware that we deployed in the data center, once it simply just runs the version 5 software, can now also exist as a WAS node pool. You have the benefit in terms of what we can do with this knowledge of the data, but you now get a next really benefit is that just over time, the normal progression of managing hardware refresh cycles becomes a very trivial matter because AppNav can now very quickly change where the flows have to be directed. Okay? Now we talked about the asymmetric routing issue, right? So asymmetric routing, at a high level is the outbound packet traverses one path, and then basically it reaches its destination, and then it follows different paths coming back. In web optimization, this becomes a problem because you end up having a different interception point processes the return path, which does not have knowledge that somebody else intercepted and processed the initial outbound. So therefore, what happens is you break the state information, and you can't get it peering, and you get basically what's called half-open or half-ended connections. And now what happens is that amount of flows wind up no longer being optimized. So you now incur more applications incur latency problems, and you wind up getting a lot of bandwidth variability issues. So what AppNav does is we take the packet, the initial SIM packet, for example, coming out. So in our example, we have a small cluster of 2 controllers. The first guy intercepts the traffic, in this case AppNav2. He classifies the traffic and then determines that based on his policies, he's going to send it to a WAS accelerator called WN1. Packet goes out to WM1. WN1 processes it, optimizes it, returns it to AppNav2 to be distributed back out to the source. Now identifies that there's another controller in the cluster, so he updates it at AppNav1 with that state information that the transaction is active and that it is now being processed by WAS node 1. Now the return packet comes back, traverses a different path, it gets intercepted by AppNav1. Now the difference now is that AppNav1 now, because that state information knows that it has to be processed by the WAS node, the WAS accelerator WN1.
James, you're cut out again.
Okay. So when the return path traffic comes in, it goes to AppNav1. AppNav1 then knows now that the WAS accelerator WN1 processed the initial outbound, and now it can forward that traffic back to that specific accelerator. So the matter now of having to deal with the asymmetric routing issue and having half-ended or half-open connections is now solved. And we solve it literally with a very simple matter of just doing data synchronization. Always the traffic, and now you get it peering between it and the branch. Now from that point forward, all of the asymmetrically routed packets going back and forth, doesn't matter whether or not there's all eight.
Jim, you're cutting out pretty severely, man.
What's that?
You're cutting out pretty severely. Actually, why don't you go to the next slide? I'll talk to it. Can you guys hear me? Yeah.
Did you want to go? Was going to do a demo, and do we want to just go to that?
Actually, so let's see what he's doing. Yeah, he's going to do a demo. Cool.
Okay.
Perfect.
And you can talk to it.
Yeah.
So let's do it in 5, Jim, if it works. 5 minutes, is that possible?
I'm sorry, go ahead.
Could you do it in 5 if that works?
So while Jim gets the demo ready, right? So just because we're cutting in and out. So with the AppNav technology, right? Primarily, what we are focused on is really trying to virtualize out and then create the ability to define your L4, L7 services networking via software, right? So effectively, when you look at AppNav and when you cut it into your data center, you don't have to, you can take virtualized instances of WAN optimization physical instances of WAN optimization, and everything gets logically virtualized, right? In the old days, if you remember, we used to put a card into the storage system and create virtualized storage pools for you from heterogeneous sources of storage. That's exactly what AppNav does. And the reason we went this route really is that most of our customers, right, they already have some WAN optimization deployed. And what this now allows is, you put this card in, and then the existing capacity gets sucked in, and it's a pool that you're managing, and then you add virtualized capacity to burst on demand. So one large fast food provider in the United States, so their approach now is for their baseline capacity, they're using physical appliances. For all the additional capacity within a data center, they're using virtualized instances of WAS.
So you said you plugged the card in, but I don't think anyone said what you're plugging the card into.
Sorry?
What's the host?
Yes.
You're plugging this card into what?
Yes. So it's 3 hosts. So the plugin of the card is into a WAS box, right?
Okay.
So if you're starting your data center deployment, the couple WAS devices, you're getting started slowly. Those devices continue to provide WAN optimization, right? But you're just putting this I/O card instead of a regular Ethernet card. Okay. The card itself is pretty extremely powerful. It has the same quantum flow processor architecture that our ASRs have, right? The same thing is put in. The reason we chose the ASR hardware architecture is twofold, right? One, because you get the high availability, high resiliency architecture that's already there in the data center WAN. Second, what we've now taken, the software stack that runs in the ASR is iOS XE. We've taken that software stack and we've done 2 things with it. One, we virtualized it out. So we probably updated you guys on the cloud services router. So if you're going from the enterprise out to the cloud, you get this virtualized instance of iOS that you can establish a secure connection with. The cloud services router also has AppNav, right? So within your enterprise, you have optimization. You choose to go do cloudburst like NASA did when the Mars rover, the rover landed in Mars. They actually burst out to Amazon, right? So then in our example, if they were using our infra, what they would do is light up a cloud services router in Amazon that has the AppNav technology. It can orchestrate out all the traffic flows to your WAN optimization, which is a serious problem when you go to cloud, right? Because you don't have access to the cloud providers' routers. You can't orchestrate traffic flow. But because you have the cloud service router with AppNav, even when you go to the cloud, you have this capability. And then this AppNav technology is now permeating all our routers as we go forward, right? The ISRs, the ASRs, and we're going to more services too. Even security services from our team will get orchestrated out by AppNav.
How are you steering?
Do you guys see the new screen now?
Yes.
Sorry?
Yes.
How are you steering the flows in the data center? So you have different paths for different classifications.
Right.
What's going on
So this is you can think of it as a L4, L7 routing, right? So it gets it classifies out the traffic, and then it's state-aware routing, right? So it knows exactly which device saw it, which is the source, which is the destination server, and so it sends the traffic. It's sending it. You can establish GRE connections, so you can force traffic to and from back if you need to too.
Okay.
Cool. And this is the WAS Central Manager, right? So then what Jim is showing is really on the central. The entire configuration and management is GUI based. Our updated Central Manager is iPad ready, so you could look at all these functions on an iPad, so HTML5 based. So what's happening here is that you go into your network, and then once AppNav is established, you literally go in here and say, okay, these 2 AppNavs, I want to associate them with, this is a resource pool available in the data center for these AppNavs, right?
So now when you're going in here, we're looking at a topology, right, that's now consists of 2 different controllers, right, and then several different WAS accelerators and and nodes. So our example we talked about, right, was to be able to create these elastic pools that we can very quickly now deploy out based on changing conditions and then new applications coming to bear. So we talked about, Kumar had indicated about the one customer right there now is deploying and doing virtualized instances very much. So if we take a look at that as the same scenario, right, let's say I want to go in here now and I've watched my monitoring traffic and I'm seeing a lot more load coming up, and I need to go in and spin up another VM instance in order to handle the capacity. Once we give a customer the pre-built OVA package, it's all about 10 minutes for that guy to be launched on a chassis or a blade server. Once that's done, we now basically come in, we go and tell them we want to add that node to our AppNav cluster. So we'll take our VWAS instance, we'll kick it through, we select which node group we want to make it a part of, we're part of our VWAS cluster, click next, select our interface, and go. happens, what we'll see now is the system now, the node is at, it will start to do synchronization, so you'll start to see on green, you'll start to see a red line come up as waiting to do its heartbeat, and that's it. It's now done. The node is now up and active, and now based on these two lines, both the AppNav controllers now see it. Traffic will now be distributed to it in according. The exact same scenario, on the other, we talked about, if you had encrypted traffic, you want to run this into a more heavy-duty device to address that specific flow. The exact same way it works. We basically come in this, or if we do a hardware refresh with an older hardware appliance, turn it on. The device will now get brought into the cluster. It's going to synchronize, and then off you go. It is brought in the most non-intrusive fashion, and no traffic can be diverted to it until such time that the interception has been validated by the controller, and both controllers in the cluster can now talk to it. Okay? And now this one is now active as well. So we just increased our capacity by both two discrete applications.
Hey Jim.
There's nothing
Hey
dynamic on the
Jim.
screen here.
Nothing's changing on the screen. Did your screen? Did we lose connectivity or no? We're still viewing your desktop.
Whoever collaborated.
Can you see the menus popping up right now?
No.
No.
So, if there's more issues, we could switch to one other demo.
Yeah.
So one other react, just 5
Yeah.
minutes. This can be done in 5 minutes more,
Yeah.
right?
Yeah. Hey Jim, I think your connection's your connection's pretty bad. We probably need to let's
move to the next one.
We can move to the next demo
Yeah,
and
let's do it.
but the summary here is that what you would do is you actually go to the central manager, right? Or you just take your iPad and then you would say this is my WAN optimization resource pool available. I'm going to associate to these two AppNav devices for controlling, and then they take over. There's a bunch of default policies, right? So if you have, let's say, 100 branches, what AppNav will automatically do is spray the traffic such that you get the highest optimization capacity possible, right? Related traffic will automatically wind up going to related optimization devices. There'll be good load distribution. All those functions kick in automatically. And that's what he was trying to show you out there. Cool.